So I am the Chief Commercial and Technology Officer for 5V Advanced Materials. I want to take you on an exciting journey on boron. So when you think about 5V, we're an advanced boron materials company, along with the lithium opportunity. And we're listed both on the NASDAQ and on the ASX, and we're going to be producing two different material classes that are going to be important for the decarbonization thematic. Boron, as you'll see, is rather scarce because there are not as many scalable resources available, but is eminently valuable to power current industries such as in ceramics, glass, and fertilizers, but eminently more valuable for future-facing applications like EVs and wind turbines. And then there's a significant scarcity associated with the boron from a supply-demand perspective. Reason being, the current incumbents, which are two entities, control 85% of boron supply globally. And because of the re-rating of demand due to decarbonization, there is more need for boron supply to come online. We intend to become a vertically integrated business focused on advanced materials with embedded manufacturing synergies and customer sticky points. And at scale, we're going to have a domestic source of US lithium, which becomes imminently monetizable or saleable across multiple vectors. And we've delivered multiple catalysts before, and we're in line to deliver more in the future. If you think about boron, and a boron one-on-one perspective, it sits across three megatrends. One is food security. Boron is used as a micronutrient all over the planet to boost yields. And given where fertilizer prices were in the past and now due to energy increases or input prices, and where the world is headed from an arable land perspective and with population growth, boron will become more and more important as a specialty nutrient. If we were to shift to decarbonization, unlike lithium, boron has multiple use cases. In wind, it's used to make the wind turbine blades that actually go into the turbine, the permanent magnets that actually power the wind turbine. In nuclear energy, it's used to control the reaction in an efficient reactor. In fiberglass insulation, it's used to preserve heat across all of the insulation around in our houses and used in permanent magnets. And when you look at domestication of supply chain, a lot of materials are coming onshore. And when you think about that from a boron perspective, a lot of these boron derivatives have significant supply concentration overseas, but find themselves in critical applications here in the US, such as body armor, tank armor, helicopter armor, semiconductors, and pharmaceuticals, and so on and so forth. So boron is widely used across these three megatrends. If you delve a little bit deeper, say, take EVs, the use cases, unlike lithium, are much higher. Think about boron steel. Boron steel gives you all of the benefits of traditional steel, but it's actually lighter and is being adopted through the EVs currently. And then when you think about textile fiberglass, which goes on top, that is also using boron to make it. And when you think about the screens inside, which seem to be multiplying and going larger and larger, they're high fidelity screens that require data for AI and automation. They also require boron. And boron electrolytes are also used in lithium-ion batteries. But more importantly, let's focus on permanent magnets. When you think about permanent magnets, everybody understands the Nd part, but forget the B part. There are two atoms of rare earths in the beginning and one boron atom at the end. But without the boron, the magnet technology fails entirely. And as I mentioned before, it's important in wind energy, nuclear energy, and also in solar energy. If you look at the project itself, we have a large traditional colomanite ore body that's in Southern California, and we're building a small-scale boron facility as we speak now, which will become operational late Q1 and early Q2 to produce boron. And then the duopoly on the supply basis supports us, right? 85% is controlled by those two entities listed above. And then one of those entities actually is going to have an expiration on their mine life because they've been operating for 100 years. And we only know about 6 projects globally, and out of which we're substantially permitted. And we're actually building the small scale plant underneath those permits. And at full scale capacity, which we've advertised to the market at 500 kilotons per annum, we'll have a mine life close to 50 years and a valuable lithium stream that actually comes out of the ground along with the boron. If you look at the demand picture, we anticipate demand to double by 2030 and go by 10x by 2050. That's being disproportionately driven by decarb applications like EVs and wind turbines. But the more telling picture is on the right, which is a supply-demand imbalance. We already see pricing double over the last 12 to 15 months because the operating rates across the incumbents are at an all-time high. And we don't see many other projects, brownfield or greenfield, entering this boron supply demand in the future, which would further exacerbate the supply tightness and manifest itself in price increases and actually starve the market. And then you could probably see boron allocation happen in certain industry segments. So this sets up well for 5E to enter into the market, to supply current markets and future markets, and have a great value proposition for current and future shareholders.